Hi everyone, this is Alex Marcham from Cambium Networks. I'm the ePMP product manager, and I think I wanted to do something a little bit different today and just kind of talk around not just ePMP for video surveillance, but just some general video surveillance topics and things around that area as well. So I'll just give it one more minute to let a few more people join in, and then I'll get started. Thank you all for attending. So I think we got a pretty good audience here. So I'll begin. Um, So as I kind of mentioned a moment ago, I wanted to do something a little bit different with this webinar and not just talk, only about Cambium products. I wanted to talk about how Cambium products can fit into a wider video surveillance solution, and then some of the other major parts of a video surveillance solution that you need to consider as well. It's an area of interest for me as well. So I'm hoping that you guys get something out of it, and we can have some good discussion, and we can all leave a little bit smarter, especially me, which I'm in desperate need of. So moving on to the first slide here, if I can manage to work PowerPoint properly. So I suppose, why would you be looking at wireless connections for video surveillance infrastructure anyway? So the principal reason is just significantly lower installation costs. I mean, when you physically don't have to trench data cabling to each camera, depending on distances from the site and everything, that can get very expensive. If you have to dig across roads or other public or private property, sometimes it's not possible at all, and it really just costs a hell of a lot more than a wireless connection, and also really restricts the speed with which you can actually deploy the system as well. I mean, typically if you have to trench, let's say you were deploying 12 cameras, which is kind of my magic number throughout this kind of presentation. You can imagine trenching 12 data cables across, say, a large car park or a kind of an industrial estate or something like that would get very expensive and time-consuming pretty quickly. So the nice thing about wireless infrastructure is you only really need power at each site, and it's much less obtrusive than a wired infrastructure option, both because of the time and obstruction with actually trenching the cable and bringing in work crew and all this kind of stuff, and also with then laying all that back down once you've actually installed the cable. So that's kind of an overview of why I suppose wireless is preferable for video surveillance. Again, probably not a great surprise to many of you, but I suppose really a very good question that I like to ask is, what do you need for video surveillance from your wireless infrastructure? So I think these are the four main points to me that are very important with wireless infrastructure, and please send me a question if you have any others that you think I should add to this. But essentially, a resilient wireless link with low or zero packet loss in challenging RF conditions. Essentially, if you've got this wireless infrastructure set up, you want to be able to monitor the cameras reliably, and if you're dropping traffic and therefore missing parts of the video left, right, and center, then it's not an ideal solution. You'll probably find your customer is not too happy if you were to drop critical frames which showed, a unauthorized entrance occurring, or if you were doing a traffic camera, if it missed a license plate, or anything like that. So that's a very important piece of it. Uplink throughput, which is very relevant to the ePMP 2000 product, which I'll cover in a moment. But with video surveillance, the vast majority of traffic is in the uplink direction, which makes sense if you think of the cameras, and on the subscriber modules are obviously going to be sending a lot more video data than they're going to be receiving any other kind of data. So uplink performance and uplink throughput in particular is very critical to a video surveillance deployment. Reliability, this may look like a duplicate of wireless link resiliency, but I think reliability for me encompasses not just the resiliency of the wireless link, but things like the actual overall stability of the unit and the wider network that it's connected to as well. And another important point is the return on investment, because whilst video surveillance is a depending where you are, it can be considered a high value service in terms of the what you may be able to charge someone for it. But obviously, the lower the equipment costs you have to pay up front to be able to install that system before you can start collecting that revenue, the better, because that just shortens your time to get your return on investment and start profiting from the deployment that you've put all the work into. So I'll just give the questions a little check here. Good, nothing yet. That's good. Just wait for me 1 second. So moving on to the next one. So why would you use ePMP for video surveillance? So ePMP is designed with wireless performance in mind in challenging RF conditions. I suppose, what do I mean by challenging RF conditions? It doesn't have to mean that you're right next to a massive tower of other 5 or 2.4 gigahertz equipment that's blasting you. It could even be things like various alarm systems operate in those unlicensed frequencies, other wireless networks in the area, Wi-Fi, possibly LTE in the future on the 5 gig side. So I find designing your network to be able to handle those kind of pressures is an important aspect if you're looking at committing to a video surveillance network contract with someone for, say, 3 years. You'd like to be able to have a reasonable degree of assurance that your affordable equipment will still be providing the service that they're looking to pay for over that whole time period, without you having to do a lot of maintenance and spending a lot of your time and effort and ultimately money doing that. We've also implemented QoS for video traffic and packet loss prevention algorithms. So you can prioritize video traffic ahead of any other traffic that may be on that link. I've got a little bit more on that later. Relevant to the ePMP 2000, the smart beamforming feature that we have in the ePMP 2000, which I'll expand on in a moment, is really optimized to improve uplink performance, which I mentioned is very critical for video surveillance. Typically, uplink performance is what suffers first in the presence of interference from our testing and experience, and it's also the direction in which the video stream is sent. So that's really the one that you need to keep in mind with a video surveillance deployment. And really, we're just able to support better ROIs than competing equipment through the combination of an affordable yet high quality wireless network. Typically you can get the same level of quality at a higher price, or you can get the same price with a lower level of quality. Problems with both of those is that if you go for the higher price, you have straight up a worse ROI calculation, and if you go for the products on the market which have a similar price to ePMP but are lower quality, you'll typically spend a lot more of your time over the life of your contract to provide video surveillance to an area, supporting and troubleshooting and all those kind of things, those kind of slightly more hidden costs that can actually far exceed the cost of the network devices themselves over the life of the contract. So moving on to the next one. So This is a bit of an explanation of the smart beamforming feature that we have in the 2000 and really why it's relevant to video surveillance deployment. So you can see that with a standard ePMP subscriber module, say connected to an ePMP access point, we did a baseline test with this particular configuration and got an uplink throughput of around 70 megabits per second. Clean radio spectrum, single device connected to the access point, pretty much ideal conditions for this configuration. You can do more throughput than this with an ePMP subscriber module to an access point, but this is really just to give us a baseline for the purpose of this test, because it's not so much the overall figure that's important here in terms of the throughput, but the comparison between beamforming and non-beamforming performance under interference. So we have the ePMP SM here. Now you see if we add a source of interference on the same channel, which is an important point, as the ePMP subscriber module. Currently we're using the sector antenna, which will listen over a 90-degree angle, so anything on the same channel transmitting at the same time as my wanted ePMP subscriber will cause me a lot of interference. So that pushes me down to around 10 megabits per second without beamforming. As you can see, that's quite a drastic drop. This is a very strong interferer. Typically the interferers that you see in real deployments won't affect an ePMP system this heavily, but it definitely serves the purpose of showing the level of performance improvement you can get with beamforming. So interestingly, when we add beamforming, which is the antenna added at the bottom of the sector on the left there, to this setup, you'll notice that there is basically no improvement in the throughput. So the reason for this is that ePMP 2000's smart beamforming is in the uplink direction, and what we will do is when it's time for the ePMP subscriber module of interest to transmit, we will create a narrow beam just purely pointed at that ePMP subscriber of 10 to 15 degrees beam width, or possibly lower than that in some cases. But in this case, as the interferer is pretty much right in line with the ePMP subscriber, it's still going to pick up that interferer as well. But you can see that as the interferer moves away, without beamforming we're still at 10, because with the sector antenna listening across a 90-degree azimuth, we're going to keep bringing in that interferer at the same power. But as we add beamforming here, we push it up to 20 megabits per second uplink performance, and pretty much the picture improves as you move further away. 20 degrees off and you're at closer to 60 megabits per second, and really just continuing that trend as you move further away in terms of the on-channel interferer from the wanted ePMP subscriber. So you can see that in a video surveillance deployment, which is very heavily dependent on uplink traffic throughput from each camera, the addition of this beamforming feature can give you a lot more leeway in terms of not just your performance today, but also future performance against other sources of interference that can pop up in the area, like competing networks, Wi-Fi hotspots, things like that we talked about. Let me just have a quick check of the questions. Okay, so I see there's one question. I must apologize. I don't speak Spanish, so I'll have to unfortunately answer questions only in English during this one. There is a Spanish webinar today, in fact starting just 1 hour after this one, so hopefully those haven't got mixed up in people's emails. If they have, I apologize, but I will have to be limited to answering questions in English for this particular presentation, so my apologies if that's not what everyone was expecting. So moving on, one of the other features in 2000, before I get on to more of the general video surveillance network considerations and things like that I'm hoping to have some discussion on here, one of the other features in ePMP 2000 that's beneficial for video surveillance is what we call intelligent filtering. So I mentioned why a resilient wireless link is important to a video surveillance system. Essentially that's your only way of getting those video images back to your command center or your recorder or your mobile device that you're viewing the feed on, and it's the only way to be able to determine whether you need to take any kind of security action, or go send a team down, or call the police or anything like that. So we addressed the on-channel interferers, the radios using the same channel as your subscribers in the smart beamforming side of things, and what we address in the intelligent filtering feature here is more around the interferers which are on adjacent channels, which can still cause some interference on your network if you have a traditionally designed radio front end. So what I mean by that is, you can see on the left here we have basically a view from a spectrum analyzer. See, the higher the signal level, the worse for you, because you want to pick a nice clean channel to operate in. So if we pick this channel, say this is a clean 20 megahertz channel. Now that's great, but the ePMP radios are designed, as are many others, to operate in the whole 5 gigahertz band. So when you design a radio front end filter, essentially, when you have a single radio device that needs to operate at some point, not all at once, but after a configuration by the user, needs to be able to operate from 5125 to 5825, let's say, for example, then you need to have a hardware design which can allow that whole range of frequencies in. So we have what we call static filters here. So the problem with this is that this larger pieces of interference either side of that clean channel can kind of leak in, basically, because my filter isn't covering it fully, and still impact the performance of the radio, even though I'm only trying to operate on that clean channel in the middle. So what we've done in ePMP 2000 is essentially we have taken this static radio design, and we have essentially made a software-controlled RF filter, so that when a user selects the channel that they want to operate on, say that single clean 20 megahertz channel, they configure the radio, and the radio automatically essentially wraps the radio filter around that channel, really helping to block out all of the interference from adjacent channels from impacting that one. So that is something else that also contributes to keeping your uplink and downlink performance clean on an ePMP 2000 system. Just have a quick check of the questions here. Yes, this webinar is being recorded, so we'll get it posted on the forum. So yeah, thank you for reminding me of that. So I'll just resume. Let me just make sure my webinar settings are correct. They are. Right, apologize for the delay. So you can see that as the dynamic filter, as we call it, as someone changes to a different channel, so you configure it to operate on a different 20 megahertz channel, the dynamic filter moves with you at the same time. So no matter which channel you choose, no matter what width the channel is, 5, 10, 20, 40 megahertz, as we support in ePMP 2000, that filter moves with you and helps to clear up the interference coming in. So I really wanted to kind of discuss more general video surveillance topics here as well. So we kind of covered why you'd use wireless for video surveillance, why you'd use ePMP as your wireless solution of choice for a video surveillance system, and then I really wanted to talk about other general kind of video surveillance system topics and how ePMP can fit into those, but really with more of a focus on the rest of the network and some of the other considerations there. So throughout this, I'm kind of using a 12 camera system, really just arbitrarily chosen. To be honest with you, I mean, you could have any number of cameras essentially in a big enough system. I've chosen 1080p cameras and using the H.264 video codec. I'll go into a bit more detail on those shortly, but that's two very common things. Typically cameras today are capable of 1080p video and all capable of using the H.264 video codec. So to support this system, I've sized out one ePMP AP and essentially 12 ePMP SMs. So for the AP, actually no, that's including the AP, the SMs, and the sector antenna is about $2,000. AP must be capable of 60 megabits per second average capacity. I'll explain a bit more on how I arrive at that figure shortly, but as to H.264, due to its operation, it's best to plan for somewhere around 100 megabits per second of peak capacity to handle events where you have a lot of activity in a scene and it generates a higher than average throughput for each video stream. So an ePMP to support that peak bandwidth, that basically means using either a 20 or 40 megahertz channel, probably likely to be a 40 megahertz channel or a clean 20 megahertz channel, depending on where you are. It's definitely achievable in a 20, but 40 may be preferable depending on your if you want to add more cameras at a later date, or if you have specific conditions in the spectrum you're operating in. And also a video surveillance network attached storage device to actually store the footage. That's supposed to be to store the footage rather than storage footage, but I'm sure you get the point. So moving on shortly, I'll probably wrap up with looking at the questions at the end, if that's all right with everyone. Otherwise I'll keep jumping in and out and losing my train of thought. So this is a really simplified topology of a wireless video surveillance system. So you can see in kind of a central office, and that really could be anywhere. It's just easiest to have it physically co-located with the ePMP access points. You can just run a single Ethernet data cable down and just plug it basically straight into the front of the NAS or into a switch, and distribute that through the building to get to the NAS. And then the ePMP AP wirelessly connects out to several ePMP SMs, which are connected via wired Ethernet to cameras just co-located just below them. Typically, and I've got some pictures of deployments a bit later on, but typically, just co-located just above the camera, so you can angle and aim the subscriber module back to the access point, and you can make sure that the camera is covering the visual area that you need it to, depending on the type of camera that you're using. So moving on, a bit more on the different video formats and things that you're likely to encounter when you're using a video surveillance system. So H.264, this is really my codec of choice for video surveillance for a couple of reasons. Primarily is the bandwidth usage. Typically a 1080p video stream, even with the inclusion of stereo sound, a moderate bit rate, tends to average around 5 megabits per second from my experience with H.264. That's assuming a reasonable amount of movement in the scene. You notice I call it a predictive video codec there. So the reason why I call that out is a predictive codec functions by every second or so sending one full complete image as a video frame. Essentially then all the frames after that until the next full image are essentially just the differences between that full image and any movement that's happened since then. So if you were to view those kind of semi-frames, I'll call them, or predictive frames by themselves, they don't really look like anything. They tend to look just like a kind of a mass of pixels, but when they're overlaid on top of the original full image, it gives you the impression of movement as a normal video would do. So when you watch it in an actual, you're watching it like on your phone or a desktop or in a monitoring center, it's seamless. You don't know that it's a predictive codec, but what that does is really save you a lot of bandwidth. So my sizing of a 60 megabit per second average, 100 megabit per second peak system for 12 cameras at 1080p really comes from an average of 5 megabits per second, so assuming the use of H.264 for those cameras. Now, MJPEG is the other one you're most likely to come into contact with today. There's some others a bit further out and a bit older, but these are the two that you're probably most likely to come into contact with today. So MJPEG is a non-predictive video codec. So essentially every, say you're doing a 30 frames per second video, every one of those video frames is a full image. So it has a couple of advantages of doing that and some disadvantages. I'll cover the disadvantages first, in that it's much higher bandwidth use. You can see it's around 4 times higher than H.264 from my experimentation. So that's a significant increase in the amount of video traffic. There's some compression and things that can be done to get it a bit lower than that, but it's typically much higher than H.264. One legal consideration to bear in mind is that H.264, whilst it's my preference, is not always applicable to every jurisdiction. Some jurisdictions across the world require that you be able to essentially identify the exact full video frame, so you have to use a non-predictive codec like MJPEG. But that's seems to be changing a little bit with some of the legal postures across the world, because you know, you can show with an increased understanding of the H.264 codec that that's what really happened in the video, but just some couple of legal considerations that I find are interesting to impact this choice. Just one moment, please. So moving on to the next one. So choice of camera. I mean, this ends up being so budget and deployment dependent. I mean, Axis cameras I've personally used. They're very good quality cameras. Depending on the kind of budget level of your client, you may be looking towards something more like a Hikvision or a Samsung camera, which is a bit of a lower priced model typically. But it really does depend on your budget and deployment. I mean, typically a larger enterprise, say you're providing video surveillance for a supermarket or something like that, often they would have, at least maybe at the corporate level, someone who has some recommendation in terms of cameras. Obviously, anything like a bank or anything like that typically has their own security team, which will have recommendations which may actually be also worked into their insurance policies and things like that as well. But it's really so budget and deployment dependent that it's hard to just say, hey, here's the camera you should use. I mean, sometimes you want a physically larger camera, to give you a better picture. Sometimes you want a smaller one, so it's less obtrusive. It's really so deployment dependent. So I can at least talk about the different types of cameras, which again is still dependent on the coverage area that you need. But I would definitely recommend, and I don't think anyone would disagree with me too strongly, that if you're looking at deploying a camera system today, 1080p is really the way to go. I mean, there's little to no real price difference between a 1080p and 720p system. It gives you a degree of future-proofing and just better picture quality, which when you're trying to do facial recognition and number plates and things like that, it just makes it a lot easier. And also, it's more of a future-proof network, I feel, as well. I mean, the difference in bandwidth utilization between 1080p and 720p using H.264 is around about 5 megabits average using 1080p and around 2 megabits average using 720. So whilst there is still a difference, I mean, per camera with a reasonably sized system, I would still look to go for 1080p personally. So kind of bullet cameras, or at least that's what I call them. These are the traditional, if you think of a traditional video surveillance camera that might be turning by itself across 90 degrees and getting like a 160 degree view kind of mounted in a corner or something like that. That's those kind of cameras. Typically have larger lenses than dome cameras, but dome cameras are really very popular because they typically support wider visual coverage areas. Purely because of their dome setup. You can get ones with fisheye lenses and things like that that can see the whole 360 degrees, admittedly with some distortion, but it's possible. Typically mounted on a ceiling, or if you have them on a pole, you can kind of put like an overhang arm, like the part of a street lamp or a lamp post that has the light bulb in. Typically it's that kind of angle, and then you put the dome camera facing downwards, just overhanging like that, so you can still get a good view of the surrounding area. Pan tilt zoom capabilities are also pretty interesting. From a network, so this is where the operator can physically move the camera lens. It's got some motorized lens assembly essentially inside the camera housing, so you can turn and look at specific areas of interest, and sometimes use optical zoom and often digital zoom to get a better view of specific areas, and also physically, like I mentioned, physically turn the lens arrangement inside the dome to focus on a specific area. Just a bit on the network side on PTZ capabilities. So typically PTZ is it's really in the it's a very small amount of data to actually initiate and complete the PTZ action between your PC or your phone and the camera. So that the throughput is not really an issue. You will see some increased video bandwidth usage if you're using H.264 when you actually do the zoom, because it's doing a lot of movement, so it needs to do a lot of full pictures, which use a lot of the bandwidth. But the actual command for you to say, hey, turn 30 degrees to the left, is not really very bandwidth intensive. It's basically like a single HTTP, TCP, do this, okay, it's done kind of transaction. So that's more of a latency sensitive, but typically it's really not an issue with the ePMP system latency. So I wouldn't suggest it's a real deployment concern, but just something to be aware of interest. So moving on, so day or night, I suppose. Really, a lot of cameras today are dual day and night modes, and it's very likely that any video surveillance client is not going to want to have two sets of cameras, and they're going to want to monitor day and night. So I would definitely recommend looking at cameras with the IR lights built into the camera housing. I've used several of varying quality, but they all are capable of providing you a decent picture at night. The only difference is that models with higher power or better focused IR lights are going to be much more capable of giving you a longer range picture at night, which is important. It's probably a good idea to try and size out at least what range of night vision your client would be happy with, but that's up for discussion with them really. But just know that there's varying levels of IR range for a camera, and sometimes within the same product family, and just worth seeing the price differences and things between those. There's not a great deal of difference in bandwidth usage in my experience between day or night, but it's sometimes you may have less movement at night, but you may have more noise in the picture, if you will, from the the infrared operation. If you ever look through a night vision goggles or anything, it's not like a totally clean picture. It has some noise to parts of it. So, and then there's many types of different specialist cameras. I was recently at a security show, and they had very expensive bomb and explosion proof cameras and things like that. So you hopefully don't need many of those, but things like thermal cameras, if you're looking at some high security areas, may be of interest. There's also very high frame rate security cameras in some places like casinos and things like that. They're known to have cameras which operate at several thousand frames per second, when a typical camera will operate at 30. I've seen ones that will operate at 1 to 2 or 3,000 frames per second for use in casinos to try and catch sleight of hand tricks and things like that. And then multispectral cameras are also kind of interesting, because video surveillance is not just used for security purposes and things like that to try and catch people doing things they shouldn't be doing. These are actually used by people growing crops to see the levels of different development across their whole crops. I can't explain this very well, but it's essentially the different spectrums of light that crops at different levels of growth stage and different levels of health will emit. So you can see those with a multispectral camera. So we've seen some deployments on farms and agricultural areas where they use that as a kind of a preemptive measure of their crop health. But it's just an interesting use of video surveillance that not just for security. So I wanted to mention that one. So good quality of service. So the way to do this with an ePMP system, and really most any other network system, wired or wireless, is really that the vast majority of cameras, unless it's like a $20 home webcam from Best Buy, any of the ones that we talked about, like Axis or Hikvision or Samsung or anything like that, you're able to configure the camera to transmit all of its video packets with a DSCP or COS value. So that's an IP or Ethernet quality of service value, and then ePMP, or like I said, most any other piece of networking equipment, will honor those and prioritize that traffic, which is what you want. I mean, typically these would be single-use networks. I'd expect it to have, you just have your video surveillance network, and that's really all it's designed to carry. But if you were also using it for, maybe you have some point-of-sale systems on it, or you have a Wi-Fi access point in the car park or something like that, this lets you keep your video surveillance network going, even if you had, some interference or something that temporarily increased your overall system bandwidth. Your video surveillance traffic would still go through, and we would deprioritize your your Wi-Fi access traffic or that kind of stuff, because that can wait. So moving on. So when it comes to storing video surveillance footage, I wanted to cover this bit because just me talking about cameras and wireless networks is not really the full story of a video surveillance system. I mean, the real point of a video surveillance system at its heart is the ultimate goal would be to have some footage stored in a secure manner which you can then, if needed, use in court or other investigation to show that this event happened at this date with these consequences essentially. So there's a lot of global variance in jurisdictions for this kind of thing, but typical guidance that I would say is that footage is really retained for 30 days, but your customers may have different corporate policies or security requirements or legal requirements depending on your area. So my advice would be to plan for storage capacity for a third extra or 1.5 times your expected retention time, just in case you have some footage that you want to keep, or something rolls over and you don't want to delete everything but you haven't got time to move it off, and you've still got enough time to keep your rolling 30 days in there. So going back to our example of a 12 camera 1080p H.264 system, if we count up 12 cameras times 5 megabits per second times 45 days, that comes out to around 2.5 terabytes, which seems like a lot of storage, doesn't it? But it's really, when you consider a single 3 terabyte disk is pretty cheap these days. I mean, even if you got a NAS which were to provide redundancy, having 2 disks in there is a pretty cheap setup today. So that's definitely what I would recommend doing. Better to have more footage than not enough. Sometimes you may have a rolling 30 days average and someone may only realize something happened 2 weeks after it did. So if you're only storing a week, then you've got to kind of answer the client as to why you didn't size the recording side of the system fully. So that's a conversation I would not really like to have. So a little bit of talk about choosing a video surveillance NAS. So I mean, reliability and storage capacity, these are really the key things to consider. There's so many models from so many suppliers available today. I mean, even like traditional network NAS guys like Western Digital and Seagate and stuff like that, they do them. There's dedicated video surveillance NAS systems which have some software in there that lets you kind of see all 12 cameras at the same time. There's so many to choose from that I couldn't really narrow it down to a single one here. One interesting capability I mentioned a moment ago is RAID 1. So this is the version of RAID which will automatically in real time create a duplicate of the active hard disk. So you could put 2 3 terabyte hard disks in the NAS. If one fails, you've got an immediate hot swappable backup, essentially real-time backup of that whole disk. So you don't lose any footage, you don't lose any downtime. You can just switch the active disk over to the backup one and then just put a new 3 terabyte disk in and you're ready to go again. You've made yourself a fully redundant backup there of the footage. So speed, I'd advise giving the speed a quick test, but it's not too much of a key concern to me these days. It certainly was with some of the old stuff. Like I once played for a while with a Buffalo TerraStation NAS, and the fastest I could get it to write to disk was like 5 megabytes per second, which was very slow when I was trying to back up everything I had inside the in the system. But really today, for a 12 camera system, a NAS only has to sustain disk write of 7.5 megabytes per second. And I put this here also as a reminder to myself as well as to anyone else whose brain blanks on them now and then, that network speeds are still measured in megabits, and then storage capacities and speeds are in megabytes. So you just take your megabits figure and divide it by 8 essentially to get the megabytes. So this is well within the speed of today's magnetic disks. I really would look at just continuing to use a magnetic disk for actual footage archival rather than an SSD for a few reasons. SSDs are today, as the densities start increasing, much more prone to essentially write wearing. So if you're just rolling 30 days video surveillance through it constantly, that SSD has to be doing continual writes, and then you have to look at an enterprise level SSD, which is much more expensive. And typically, from my experience, if an SSD, cell, one of the actual bits stored on the drive goes, it's typically a much more involved process to get that back if you can at all. Whereas typically you can run a tool like SpinRite or Disk Doctor or something on a magnetic disk, and unless it's been kind of had a spike driven through the magnetic platter, it's pretty much ready to go. So that's my recommendation on the storage side of things. So monitoring software, I haven't got many more slides to go, so please don't worry. Then I'll get on to the any questions that are there. Thank you all for bearing with me thus far. So video surveillance monitoring software. So pretty much any camera you buy will have some of its own software. You can always log in to the web page of each camera and kind of have a bunch of tabs up and click between them, but that can get a bit unwieldy if you're going to have, let's say 12 cameras as our magic number for this network. But this will let you have full configuration and access to pan tilt zoom functionality. The pan tilt zoom one is probably the trickiest part, because you can typically configure some of the higher end cameras via eSNMP and things like that, or via a REST type API. But many other applications like Windows Media Player that can be used to view the video don't allow you to actually action the PTZ capability. So this really depends on the type of camera you're deploying and really what the guy monitoring it, whether that's you or another team, need from their camera viewing setup. So just a few options there as well. And there's also various monitoring software suites that kind of will give you access to the PTZ, and they'll put a bunch of third-party features and things, and let you do panels of, say, 10, 12 cameras on the same screen and that kind of stuff. So some of them are very advanced, but again, there's so many, I struggle to really come down to a single one to recommend at this point. But I can certainly look into it if anyone's interested in a recommendation in that area. One thing that's also important to bear in mind is actually how you're going to monitor the network. So I see this as two sides of this. So you've got your traditional network monitoring side, where you've got SNMP, syslog, SMTP, all those kind of things that we deal with day to day in just network infrastructure. But then you've got the actual job of monitoring the network footage. We've all seen like the security guard sat there looking at the screen and probably looking kind of bored after about an hour, because there's often not a lot happening, hopefully, in your video surveillance footage. But it's debatable as to which is the best way to go on this. Typically, a rule of thumb is obviously anything like a bank or a higher security area is going to want a manned monitoring station, so that they can be sure that they get a in-person response to anything that happens, like an intrusion or a movement alert at night or something like that. But some of these things, like if you get say you're doing a supermarket CCTV, often an unmanned approach is fine, and you just have it set up. You can configure each camera to say, hey, if something at 10 p.m. crosses this line, so someone goes in the front door of the supermarket after hours, sound the alarm, something like that, right? Send the security team and the police an email and sound a local alarm. You can do things like that. So really is driven by the cost that the client is prepared to put in, and their response time needs, essentially. A lot of cameras and network NAS, video surveillance NAS systems today will also support remotely monitoring in real time via apps over Wi-Fi or 4G, which is pretty cool, really. So I definitely look into that as a capability as well, because so often, like any other network or service you put in, you just want to be able to just quickly check it's still working, and someone calls up and they have an issue, you're just able to open your phone whilst you've got them on a call and just say, no, it's up, it's working, rather than having to go out and go back to a central location and fiddle around with it. So nearly at the end here. So this is just a few images of some video surveillance deployments. That's some of my favorites. So this is an ePMP access point in Budapest. This is providing the downtown video surveillance CCTV network in the city. So this is the AP overlooking this rather nice Ferris wheel in the middle of town. So when you get down to the street level, what they did here was a pretty cool deployment where they had that kind of an arm sticking out the side of the building and a few SMs up there to connect to various cameras down the street back to the access point. You can see the dome camera is on kind of an overhang arm, like I was attempting to describe earlier. So you can see that the the black part at the bottom there, the whole lens dome assembly. He's got a great view of the area below the installation, which is the whole reason why you'd want to install a dome camera. So that's quite a hefty dome camera. I believe that one also has some heater functionality to prevent the motor, seizing in winter and things like that. But I think that's a great deployment. And really the same here. This is a similar angle on one of the systems a little bit down the street, slightly smaller site on the side of a different building. But you can see again the dome camera has a great view of the street, which is exactly what you want. And then this is a view of inside their network operations center. I mean, obviously for a city center deployment, they've got a manned setup here. There's always someone in this room monitoring these feeds, basically day and night, and they have obviously security forces and police on call to react to anything that they see, and ambulances and things like that for car crashes. But even if you don't deploy something that's this big, say you've got one monitor or two monitors worth of screens here, it can still be a pretty impressive sight to see all the the real-time video that you can pull back over a wireless system like that. I think it's pretty cool, and its most cool thing is it lets you really actually make those business opportunities viable. So that is it from me in terms of the presentation. Hopefully I didn't bore you all too much. Let me see. I have a couple of questions here. Discuss video surveillance with you. Okay, I can follow up with that, chap. So, any questions, guys, or anything you want to discuss just before the end of the webinar time? Thank you. I wanted to do a presentation that was a little bit more around the whole use cases and wider issues rather than just talking about our Cambium products. So hopefully, if this is something that you guys enjoy, I'm more than happy to do more of them in the future. So thank you very much. Yes, I can send a link to the slides. I'm also recording it, so I can put them both up on the Cambium community forum a bit later today. And anything that you guys want to discuss about anything like this, or video surveillance, or other applications as well, and hopefully this is the first of many that I'll do in this kind of format, then just please let me know. If there's a specific use case or something that you guys want to hear about and discuss, I'm more than happy to. So thank you everyone for your kind comments. I'll just give it a minute or so to see whether there's any questions, and if not, I'll close out the webinar. So one of the questions is, for video surveillance, what would be the principal advantage of Cambium over Ubiquiti? So to me, with the stuff that we talked about, the real advantage is that over time I can only see the interference in basically anywhere on the planet increasing, especially when you're talking about 5 and 2.4 gigahertz bands. It's completely unlicensed. I can turn up next to your network tomorrow and just start broadcasting basically anywhere I want within the legal power limits. So to me, really the key advantages for the video surveillance use case for Cambium over Ubiquity, and principally ePMP over Ubiquity, just for the sake of this, is that it really takes you to the next level of interference tolerance and ability to provide a reliable quality video service to your clients. Typically what I've seen, and I've personally deployed them in some deployments around the local area, is that when we've deployed Ubiquity systems with a small number of clients, they typically perform quite well in clean RF conditions. When you begin to add clients, or you begin to see increased interference around you, or even both, which is the worst case, typically the reliability, performance, and the resulting video quality basically resulted in becoming quite choppy. So I would say the real advantage is that for very comparatively priced equipment, you can provide a much higher quality service, letting you basically get on with everything else you want to do without having to troubleshoot and constantly maintain a kind of marginal performance network. So that's my best answer to that one. Afraid of it's a bit long-winded. Is the ePMP 2000 capable of both SM and AP mode? Yes, it is. Absolutely, it is. Sure. So I see one of the questions here. What I'll do is get one of our Spanish-speaking team to send you an email at that address, and you can get the lowdown from him on the core advantages of Cambium over Ubiquity for this use case. So I'll just give it a couple of minutes to 9:55, and then I will close up the webinar. Thank you all again for joining. Thank you for the kind comments, and hopefully I'll do many more in this kind of style. I do enjoy the more conversational approach and less of a product-specific thing. You know, because if you can see how the products fit into a wider network and the challenges that you then have of making the whole network work, that to me is the most interesting part. So glad that everyone else also got something out of it as well. Okay, so I'm just going to end the webinar here, and thank you for everyone who joined. I will have to. I see a couple of the Spanish questions. What I will do is I will take those and take you guys' email addresses and basically pass them on to our Spanish-speaking team, and they can give you the answers to those. So I apologize that I personally can't answer those at the moment, but afraid my language skills are somewhat lacking in that regard, but hopefully you'll bear with me. Okay, so thank you again everyone for coming. I'm just going to close the webinar now. There is a webinar actually in Spanish in about 5 minutes. Hopefully everyone who's registered, if you're going to that one as well, you've already got the email to join. And thank you, and I will see you all again soon.